Welcome to this video on determinants. Now, we are going to use determinants to basically find the inverse of a matrix, but determinants themselves do have many uses in applications, including ones in the real world. I won't get into all the uses, I'll just get into how to use them and how we're going to use them for our A-level maths. So first thing, if we have a matrix M, and that matrix is A, B, C, D. Okay, now for determinants, they need to be, square matrices. So we're only going to do them with 2 by 2 matrices this year. Next year, I can't remember off the top of my head if it's FP2 or FP3. I think it's FP3, where we use the 3 by 3 matrix to find the determinants and find the inverse. Now, the determinant is sometimes written as the modulus of M, or the modulus and the matrix inside that modulus sign. Okay, and what it is AD minus BC. So it's these two multiplied together minus these two multiplied together. So if I have this matrix A, the determinant of A is AD minus BC. So AD is 4 times 5 minus BC, which is 2 times 3. Or 20 minus 6, 14. Okay, so in a lot of cases that you will deal with, the determinant will just be a numerical value. Now, sometimes in some questions there might be an unknown. You might be given the value of the determinant and then use that to find the unknown, or to find it in terms of like A, B, X, Y, P, Q, etc. So let's have a look at one of those. So here is my question. Okay, you can see this time I've got it in terms of P. Given that A is singular, find the value of P. So first let's look at the determinant. So the determinant of A is 5 times 3p minus 2 times 5p plus 4. So it's these two multiplied together minus these two multiplied together. So that's 15p plus 10p plus 8. So 25p plus 8. So that's the determinant. And obviously, instead of writing det A, determinant of A, I could have also put A in a modulus sign. So we've got the determinant in terms of P. Now, how do we go about solving this problem? So it says given that A is singular. Now, we haven't got onto this yet. This is the next video, as it so happens. But to find the inverse of a matrix, we need the determinant. Now, when a matrix has no inverse, it has no determinant. So the determinant is 0. So if I'll use M, the determinant of M equals 0, it's singular, has no inverse. The determinant of M doesn't equal 0, then it's non-singular. It has an inverse. Inverse. Okay, so this one being singular means the determinant of m, or in this case the determinant of a, equals 0. So this equals 0, therefore 25p plus 8 equals 0. 25p equals negative 8. P equals negative 8 over 25. And that's all there is to it. Okay, so that now is introduced the singular and non-singular. And just to reiterate, a singular matrix has no inverse, and a non-singular matrix has an inverse. Okay, and then that's the same with 0, not 0. So okay, so this is quite straightforward, and like I said, this is really just building up towards inverting matrices. So I'll just give you a couple of questions to try, and yeah, once you have a go at them, check the end of the video and head on to the next one then. Oh, and while I've got you listening, don't forget to like the video. I know everyone on YouTube says that, but you know, it does help. Helps me anyway. Obviously doesn't really help you, or maybe it does. Maybe YouTube sees you're liking these videos and it brings you up similar videos. You might find some other YouTuber that explains maths better than me. I don't know. Well, anyway, so yeah, like, subscribe, comment down below, and if you want to try and help me out a little bit financially, then just consider hitting that join button. Join for a month, join for more. It's up to you. So here are the questions, answers at the end of the video. Pause the video now. So part A, finding the determinant. The determinant equals 4 times 7 minus 2 times 1. 4 sevens are 28, minus 2 equals 26. So part B, the determinant of that is minus 1 times 5 minus 2 times 3. That's minus 5 minus 6 is minus 11. See? Right, so the determinant is 4 times 7 minus 2 times 8. So 4 times 7 is 28 minus, and minus 2 times 8 is minus 16. So that's 28 plus 16, which is 44. And then finally D. So minus 3 times minus 5 subtracted minus 2 times minus 6. So 15 minus 12, and that is 3. Question 2. Given that k is a real number and that m is this matrix, find the exact values of k for which m is singular. So the determinant of m is minus 2 times k minus k minus 1 times by 1 minus k. The other way around. Right, minus 2k minus, now I'm going to do this, so k minus k squared minus 1 plus k. So minus 2k. So in here we've got minus k squared plus 2k minus 1. So that is plus k squared minus 2k minus 1. So k squared minus 4k minus 1. Singular, so determinant of m equals 0 as it's singular. Therefore, k squared minus 4k minus 1 equals 0. Sorry, I've just realised minus and minus is a plus, isn't it? So that's a plus 1. Sorry about that. So just to reiterate, that makes that plus, that minus, and that plus. So at this point, you know, obviously your calculators can give you the answer, like 2 plus root 3 or 2 minus root 3. But the exam usually says about sufficient algebraic working out. You know, so for the further maths, it does expect you to work this out. So if you cannot factorize it, what you do need to do is you need to make sure you can use your calculator. You can use your calculator just to check your answer, but you need to use the formula in this case. So minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so that, if I just carry on up here, is 4, positive 4 now. The square root of 12, which is 2 root 3 over 2. And then, you know, you can factorize out 2. Obviously, I would do this in my head bit, but factorizing out the 2 and the 2's cancel. So 2 plus or minus root 3. So k equals 2 plus root 3 or 2 minus root 3. But make sure you're doing this bit. From here you can jump to here, but make sure you are showing sufficient working out just to gain all of those method marks. Okay, now that's the end of this video. It's nice, short, nothing too difficult, but we'll get into the inversing next time.